Hey, how's it going, guys? So here we are back again, Python, BACnet Stacks Playground. So today I want to play a little bit more with these grid search algorithms. So we have some more AI generated daily mini challenges, just to kind of study them a little bit. Um, and yeah, let's kind of continue on with that. It's part of this Vibe Code app 23. And I have to open up another instance of cursor here. So this might be a little bit hard to see, but this one right in front of you is this is actually how I'm doing like the open FDD development. So every night I make basically do some testing um, during the daytime, and then GitHub Actions will make another refreshed Docker containers. So let's just open up this. I'll do this on a different window. Um, Well, basically, I put cursor. I like doing this, putting cursor into plan mode. And then it's actually going to create, um, just run a whole bunch of testing, automated testing. So like I did some updates to the user interface. And then I'm also having it build MQTT secure pipelines into it. It's basically a knockoff, pure knockoff of AWS IoT Core. So basically, and I'm testing this on, this will come out later. So this is a web app service called Railway. Um, and it's actually really slick to deploy just web apps, especially if they're come from a Docker container service, and then ones that are published to the GitHub container repository, which OpenFTD is. Um, and Docker Hub would be another one. But so it's really slick. It has its own like chat interface, and I could just basically just tell it to um, install OpenFTD. The railway agent right here, it says it uses Anthropic. It's one of Anthropic's models. It doesn't even know which one it is, but it knows it's Anthropic, a Claude model of something or another. So basically, it just bootstraps OpenFDD, which is really freaking slick. So this is coming soon, where be able to install OpenFDD on the cloud um, for like $5. There's a free version of it too. It's just like you wouldn't have a lot of RAM and a lot of hard drive space to play around with. But so coming soon, something that'll be like uh, build to stream data from the building to the cloud for dirt cheap and run HVAC analytics and fault detection. Um, and then also part of this is I want to post some bug bounty professional hackers basically. So uh, this instance right here, that's just like my hobby development work. I want to post it on Open Bug Bounty, and some other people responded to. There's a Git issue in here for this where uh, just here. I was kind of surprised with this. So like I did, this is just notes of mine. I'm just like putting notes out here, and like a couple of people even responded to it already, and they're not even people in the HVAC industry that I can see. I think there are professional like bug bounty person like this guy. He's wanting to know, is there a bounty for finding bugs and vulnerabilities where people could hack and exploit the application? And yes, and to that question is like what I want to do even as a hobby for me is I'll probably always have some $5 instance of this running for testing purposes, and like $100 a month, why not? I think that's still pretty cheap. That if someone wants to play around with their hacking tools, and if they can find a vulnerability, eventually I'd give them $100. Maybe just starting at 25, because they're probably like quite a few or something, I'd imagine. And then as they get a little bit harder, maybe get up to 100, and then if there's other people interested in this project, it could be like a community funded thing where yeah, that'd be really cool. And the neat thing about this too, it's like this is how open source applications get really secure. Is when they're on when they're being validated like this. This is exactly what this project needs. It's I need security perspective way more than what I'm capable of. Um, and I'm kind of excited for this. If you listen to Darknet Diaries podcast enough, like this will totally make sense. And some of these people that do this for a living, they've been hacking for a really long time, and some of them have even gone to prison for hacking. And now that they're out and allowed to use computers again, they're doing this kind of stuff and getting paid for it. Sometimes they're even working for some government. Um, so yeah, it's that's where I'm going with OpenFTD. I'm hoping to post about that too coming soon. Is like you'll be able to bulk load CSV data sets to the wherever you want to host it. Um, and then also MQTT pipelines, and then supporting BACnet, Modbus, and Rust, all from Justin's stacks here. So like I notice Justin has been updating some of his. This looks really interesting too, so maybe we'll play around with that someday. Um, Open control engine. I have to wrap my head around what that is, but I noticed he's posting updates to Rusty Modbus, Rusty BACnet, and then Rusty Haystack's another one. He's got a whole bunch of stuff in here that's really pretty interesting. So, but yeah, okay. So like, let's get back to Vibe Code App 23. Um, for just some AI generated daily mini challenges on grid search algorithms with a calibrated EnergyPlus model. So I'm just going to start this is my cursor. Cursor agents are going to build for me open FTD, like what I was just talking about. So I'm just going to get these guys up and running, and then I'll probably circle back with them tomorrow. So what they do for me is, if you guys can read this, they do handle all my GitHub stuff, watching GitHub container publishes, clean up stale PRs, pull requests, ensure there's no stale actions, failed GitHub uh, branches. And then they're also going to run some BACnet testing. I kind of have some sophisticated tests that they do on a test bench. This is the Workbench tool, which is running on this computer I'm recording this YouTube video from. Is like I have my test bench, I have this BACnet MSTP device. That's a JCI FEC. So the OpenFTD application will use Rusty BACnet to pull this, publish it to MQTT, validate that the data ingests into SQL, and then run some really basic fault detection check that fault detection runs okay. And it also does it on two devices, so it'll run it on. This is the server here that it'll run it on, and then also one of my Raspberry Pis. It'll also be running MQT pipelines back to this guy. So it's just like some nightly regression tests as OpenFTD develops. Um, yeah, and create a bug report. And then I do this every day. It's part of my daily workflow. Is I do one, piddly update to OpenFTD, some UI enhances, and then run these rigorous tests. OpenFTD has Python. I want to write about this in a future blog, but there's a Python version of the fault equations. Actually, I might as well just show you guys this. And sorry for getting off topic. Um, but so OpenFTD if I go down into the, join the Discord server, here's the docs. Patchy arrow, I have to fix that. Um, so, well, maybe I found a bug. Okay, so the docs are broken. Okay, whoops, no, actually, sorry. Being stupid, that the wrong links. These are just the pins. This is the only one that works, but sorry about that. Uh, um, and then okay, so pandas. These are fault detection rules in Python. Pandas computing library, and then they're also in the SQL as well. So here's the data model in Haystack. And okay, so SQL version of the fault equation, and then redundant version in Pandas, the Python analyst library. So what I also do during some of these tests is I have a synthetic data set um, where it's very just like an hour's worth of data, and then it's very obvious like a sensor fault. Um, so it's just a confirmation, like a very rigorous, easy confirmation that the fault equation works. And then it also snapshots a component of time. So like what we want to do in fault equations is uh, capture the lapse time that we've been in a fault mode. And some of it's useful for energy engineering calculations. Um, so I have this. My point is like I have this regression test that runs at night, compares that SQL rules equal the Python computing rules against the same synthetic data. Um, and I found a whole bunch of bugs in that too. So it's yeah, it's getting better and better. And I'm really excited for this railway process as well. So yeah, and we do have there is like let me see, this is so zoomed in. It just looks different to me. But okay, so I just have to zoom it out. So that's so here, these are these GitHub packages that this is what Railway will clone, and people can run this locally too. Is the Railway AI agents? This is where the called the GitHub container repository. It's just Docker images. So you do Docker pull, and then the Railway agents on the web app hosting service, like they know just what to do and to get the project bootstrapped and everything like that. And I think it'll be might be really nice too, because I think I can use Railway too as like some with this model context um, one that'll be used for just thinking out loud here that the Railway agent can use to help you too. And there is a whole bunch of these numbers have to be off. If there's 5,000 container downloads, I would be surprised. Um, anyways, so that's updates on that. Okay, so like I think we can get down to. So I'm gonna tell these guys to build, and we can go. That'll be my OpenFTD test for tomorrow. And then sometimes I even drag one of these things in here as a queued prompt and say, please ensure this finished. And with no stale GitHub actions. And it's really laggy for some reason. Or branches or sorry, this should be failed GitHub actions or stale PRs. So I'll just queue that prompt. And then it's just kind of like my proof that usually that they finish. And then I can usually check on my phone too, and I can see the emails coming through for failed GitHub actions, and I know that they're fixing something. So it's kind of nice to have that redundant check. Okay, so like I open up the second instance of cursor. So I'm going to zoom in here. And then what we noticed yesterday was okay, so switching, so done with OpenFTD, switching back to Python and BACnet Stacks Playground in this vibe code app 23. This was this LBNL Building 59, which is a public data set on the internet from 2020 or so. And it has a complete telemetry, occupant loads. I was doing some research about, I wanted to play around more with like these calibrated EnergyPlus models. And then maybe some more of this grid flexibility algorithms. And then especially if it's in a place of high demand charges, because the last write up, the economics were just not there. Because I think like the demand charges are just too, they're too cheap. And like the last video I mentioned, I remember hearing people in that may work professionally in demand side management full time that they basically weed out projects. I think for like battery systems, if they don't have a $20 per kW charge or something on their utility bills and their rate tariffs, that they just kind of they know that the ROI just won't be there. So I think like the way that this grid search algorithm works is like it's calculating utility costs in real time based on the calibrated EnergyPlus model. Is like if the demand charges are really high, or if there's time of use rates constantly changing and kilowatt hour, dollar per kilowatt hour, that economics will be there. In the last vibe code app 22, it just the costs weren't there. It wasn't worth it. Basically, what the client was doing with the optimal start algorithm, which we talked about previously, is like I couldn't beat it from a cost perspective, but I think it would have if the demand charges were high. So this is what spawned bytecode app 23, and where are we going with this? And this LBNL building in California with it, public data set available in California is probably one of the worst demand charge places on the planet. Maybe we'll be there. So let's dive into it. I should be doing this economic thing ahead of time, but let's do it the interesting way, I guess. So yesterday we left off with so this must be this the best EnergyPlus model. So it did find a winner for meeting guideline 14. And we should get into these terminologies too. So I'm gonna ask ask it to do a few things. Maybe put you in plan mode. So I'm gonna say for that, can you that's the best E plus model. Can you make some charts per month for the, let's see, these are the net mean bias error for guideline 14 and the root mean squared CV root mean squared error versus actual usage. Then make some electric load profile charts to view with E plus versus actual and a percentage difference. Electric load profile shapes in the same format as these guys. So we did a whole bunch of that in Vibecode app 22, so I'll just drag that over there. And then we need to see one on peak demand from that best calibrated EnergyPlus model versus actual as well. And then do a commit and push to GitHub and no stale PRs or branches or failed GitHub actions, please. Okay, so cursor is going to go into planning mode. And then we should jump back to do one or two of the daily mini challenges for the in the Vibecode app 23. Okay. Gosh, everything is just really laggy today. Okay, so I noticed like cursor does like an update every other day. And sometimes what they do is it's just automatically selects models for you to use. So it looks like Composer 2.5, they haven't had that for a while. Nor Fable 5, I've noticed, but Soul is back up there. ChatGPT, Soul 5.6, Opus 4.8, Opus 5, and Grok 4.6. So I guess by default, that's what they're using. I noticed too, like when you use cursor models, that they really discount the heck out of it. So like, yeah, Composer was fairly decent model. I don't think it was as good as ChatGPT 5.6, but good enough. Like from the AI bloggers, and they read all the research reports on how smart the AI models are, comparing it to another. It was not that bad. So they were saying at the time, maybe a month ago, that your high models, enterprise models, you create your plan like this. You know that the smartest model creates the plan, and then the cheapest model does all the work. And then I think sometimes the smartest model critiques it. That way, it's like the cost per task is cheap versus just coding everything in Fable 5. It would cost really expensive. So yeah, I think that's what's probably happening under the hood is it's like model routing going on. I think like the concept of model routing is that the if there's a really easy task, like I have GitHub, or I have these the agents watch GitHub actions, and it's just system watches like that the red light, green light, something fails, like a web request, 200 or 400, like you could have like a really easy task like that. It should be like the most cheapest of cheap models, or even better yet, a local hosted model. And then you only use these expensive enterprise level models to do create these plans and critique. So it looks like this is almost done. I'm just gonna wait till this is done. Hit the build button, and then we can get off to the races for the other stuff. This is also a CSV file that I think we talked about this yesterday. Just comparing the like the real data from the LBNL Building 59 to settings in the EnergyPlus model in the IDF file, that they're pretty close, that they're apples to apples. So I think we did yesterday in Visual Studio Code. Looks like that's going kind of slow, so maybe I'll just proceed. Um, okay, so yeah, how did we do this yesterday? We were just maybe I will just open up everything in the directory. Give me 1 second, guys. Let's see if this is still building. Looks like that's still building anyways. Okay, so here we are. I keep all my junk. I'm just gonna go, let's just use this guy. Script lesson. This must be something from a long time ago. Just studying basic Python. Data structures, so that was a list if you remember. And then this was, no, I'm sorry, this is a dictionary. And then this is a list of nested tuples. So this is probably some challenge that we were doing a long time ago. So like these daily mini challenges for EnergyPlus is not too much different. It's just passing data to these simple data structures, and then eventually I think we'll call EnergyPlus through like the CLI or whatever. We'll call it some way. I can't remember how to do it. Okay, so here we go. Cursor has some questions. For peak demand, which Vibe 22 style chart do you want? Monthly KW bars. Let's see, what do we have here? Monthly KW bars measured versus for each month. Yeah, why not? Check back with that in a couple minutes. Then let's go right into the. Let's see, we're in Vibe Code app 23. Where's the lessons here? Okay, so we were studying. I think we looked at the code from yesterday here. My computer is just running really slow. Yeah, everything's running really slow. So here's day 2. So we looked at this yesterday. Python, we have all of our, this would be pretend hourly weather data fetched from the internet. Then like, so this is part of like the grid search is like, these are the setbacks that it gets to play around with. 60-degree setback, 62, 64, 66, 68. And it has like all these different, a defined fixed amount of actions it can play around with. Kind of reminds me, the little that I know about reinforcement learning, like Q learning, is that there's like a table, an action space table. Pretty decent sized program for a tutorial. Python. Oh, that was fast. So the computer crunched all those numbers like really, really, really fast. Because I think they were just simulated. First of all, they were just dummy values. So hopefully you guys can see this. I'll try and zoom in one. Okay, so when we ran that day 2 code base, fake data, grid search, the toy model, not EnergyPlus. So tomorrow's hourly weather forecast. I think they got something wrong in the way that printed. So this would be, oh, maybe not. Hour 3 is -9, hour 4 is -8, 5 is -6, this would be in degrees Fahrenheit. 9 o'clock in the morning, 17 degrees. This would be kind of a pretty radical shift in weather if it was a real day. That by 1 o'clock in the afternoon, that it got up to 23 degrees Fahrenheit, and the day started at -4. You know, I've seen wilder things. But the idea is that that could be like a really costly startup for the building. And then these are just fake numbers, fake kilowatt hours, fake peak demand, on peak demand, compute costs for running that model. And then this would be the cost difference from the base cost. Okay, so I think we kind of get the point of that. Let's go on to the next day. I might just switch back to see if we can build. Okay, so I'm going to see if we can build this, and then we can look at this tomorrow. So vibe code app 22. We can go see these. I'm sorry, this is vibe code app 23. We can just go look at the LBNL Building charts for electrical load profile shapes. These percent differences charts. And build. So easy. It's like cheating. Prior to all of this AI stuff, someone would have to go create a bunch of pandas code bases and analyst work and make charts. Now you can just have the AI machine do all that for you. Look back on the other one, see if he's running. Okay, so this guy's running too, so we can let AI agents do their thing, and then we just have to basically sit back and play. Let's look at day 3, and then I am probably going to sign off after this one. So this is where we get to use EnergyPlus for the first time. So this will be to prove EnergyPlus toolchain works. Locate, I'm on Windows, the .exe. I installed EnergyPlus for Windows, which I think EnergyPlus, to my knowledge, is a compiled C++ application that runs under the hood. So it's like a really fast and efficient physics computing engine. It's been around for a long time. Yeah. Okay, run one stock example for Chicago and read. Okay, so no grid search yet. Concept. Before mutating schedules, confirm that the example files resolve. The weather file for Chicago resolves. A 1-day run period completes without fails, and a time step CSV outputs are parsable. And then this is actually this one zone uncontrolled.idf It's just the simplest bare bones EnergyPlus file. Let's just look at that. So if I go to my C drive, I can go here, example files. Say, where was this now? Just gonna search for this. Search. Okay, so it is this right here. One zone uncontrolled. Gosh, that's annoying when it filters it like that. I think it's this right here. One zone uncontrolled. Let's see, it's been a little while since I've had to open up EnergyPlus. EnergyPlus. Not much to it. Okay, let's oh, you know what we could just do? So this is the EnergyPlus editor. I might even just open with VS Code. Okay, so this is text file for EnergyPlus. I'm no expert in any of this, but it's basically just the zoning is just a box. So picture like my little office right here, just with nothing in it. No people, no windows, no shading, no daylight, no solar distribution, no air conditioning, nothing. It's basically a shack with some really highly advanced algorithms to run all the physics. I think these are comments in EnergyPlus engine under the hood, and then this it'll actually run these as variables. Denver. So basically, when we ask AI agents to do all of our guideline 36 tuning under the hood, they're modifying this stuff, this text file. They're supposed to be looking at the EnergyPlus model context server, where the documents for EnergyPlus are just enormous, like thousands and thousands, 5,000 pages of PDF. So I can only imagine that the model context server is really large as well. So, and what they're doing is like they're hitting the simulate button over and over and over and over and over until we match up to actual fuel usage. So I think there's some people that can definitely run circles around me in EnergyPlus, and just be aware. I know just enough to be dangerous in this world. I have not done energy modeling full time, where some people have. So I just have like a bare bones minimum experience in this. But so if you see something that I'm doing wrong, drop me a comment or shoot me a message on Discord. There's definitely room for improvement here. Okay, so like what we want to do, so I'm just gonna clear this. So this is just PowerShell down here in Windows terminal, and then this is EnergyPlus in the background file. So this is my terminal. I just went to opened up a new terminal here. So terminal. Okay, so then I clear that out, and then let's just try this. Python script for check the EnergyPlus install. Okay, pass. So it's found the EnergyPlus engine, the executable, Chicago weather file, and this simple. Probably because I made this lesson on this computer. Okay, so let's try this. Let's run a sim. Oops, I think something weird happened there. Okay, so it just ran a sim on this really simple building here. Didn't show any fuel use. Okay, so it's what is the micro exercises? Okay, so we did this runtime in seconds and CSV count. So I think it's basically just simulating this building. Runtime. That doesn't make any sense, but anyways, I think I might just stop it for here, guys. So this is just basically just getting used to these daily mini challenges. Is it's just supposed to just get used to how to run EnergyPlus from Python. And then it's supposed to output some kind of like CSV, some CSV data. See if it did anything. So if we go back into outputs, runs, so this is some CSV data where it'll give us some stuff to look at. Looks like some data every 15 minutes. So outside air dry bulb temperature in degrees C. So it's crunching some numbers. Wow, like tons of physics stuff. Like goes on under the hood of like people with deep theoretical knowledge of mechanical engineering and heat transfer, that actually make this program over the years. It's really impressive. But so I think you get the idea. And then like the next couple days, I think it'll just be a more complicated EnergyPlus model and combining it with a grid search. And that's we'll kind of play around with getting more complicated grid search stuff, and then maybe eventually just seeing if it's interesting to run on this LBNL 59. That's the goal. So hope you guys are liking this, and I'll talk to you guys tomorrow.